Welcome to teaching physical computing with Arduino. Before we get started, let's take a look at the content we will cover and the format of this course. As you complete this course, you will learn how to find materials to build and organize your classroom set, navigate and use provided resources to limit planning time and maximize hands-on learning, understand how to best debug issues in code and physical devices, and direct students to projects that will captivate their interests and give them the tools to complete self-directed projects. The format of this CodeHS course includes short videos, connections, notes, and free response questions. This course is completely online, so all you will need is a web browser. Some previous experience with the CodeHS platform and LMS is helpful, but certainly not required. This course is completely self-paced. You'll work through modules online, which will take approximately 5 hours to complete. You'll also have access to the CodeHS team. If you run into questions or need a topic or exercise clarified, just ask using the conversation area in each exercise to receive personalized feedback from the CodeHS team. You'll also have access to teacher forums and the CodeHS curriculum, resources, and tools. Be sure to make the most of this PD course. Lay out a schedule for completing the course. Setting some deadlines for yourself often helps ensure that you'll complete the course. Don't hesitate to ask questions. Remember that we are here to help you. And don't rush through the course. Be sure to watch all of the videos and spend some time working through the course activities and reflections. All of the resources included in this online PD course are here to help you teach your physical computing course. Let's take a deep dive into the course overview. This course was designed to be taught in 1 quarter to high school students. It is not recommended to use this course in middle schools due to the level of complexity of the Arduino device, the immediate need for a breadboard when building circuits, and the more syntactically stringent C++ programming language. For these reasons, we recommend teaching physical computing with microbit to middle school students. The course provides a highly interactive way for students to apply programming concepts to physical devices. This course is meant to refresh and apply basic programming concepts in a physical environment using the Arduino Uno device or a third-party equivalent. Throughout the course, students will test and compile programs using a computer simulator and build circuits to run the programs on their physical Arduino devices. To simulate circuits and programs, students will be using the online software Tinkercad. To transfer programs to their physical devices, they will use the free Arduino IDE. We have created step-by-step documents that will let you know exactly how to set these up and use these programs, and we'll discuss these later in the module. There is a strong focus on discovery learning in our physical computing course, so we encourage students to hypothesize and test what commands do on their own through the use of what we call explorations. These step-by-step documents include diagrams, starter code, and questions to guide students to learn about new commands and how they are applied in their programs without being directly told by their teacher. Each lesson in the course contains an exploration, so students are constantly exploring new commands to add to their physical computing toolbox. To help you implement this course and keep track of all of the resources, we created a single document that has all the information you need to be successful. We will take a deep dive into all the resources for this course in the next lesson. The Arduino course is broken into 3 modules. In the first module, students learn the basics of the device by controlling LEDs and motors and using variables to structure their programs. In the second module, students apply control structures to their programs along with sensors and additional components. They'll use temperature, light, and distance sensors to detect attributes of an environment and have their programs make decisions based on this information. In the advanced Arduino module, they will get to apply all of their skills in completing more complex projects. They will do independent research on sensors, complete an existing project, and eventually design their own. I previously stated that this course is meant to refresh programming concepts for students. What this means is that basic programming concepts, such as loops, functions, if-else statements, and variables, will not be taught from scratch in this course. Students should have already seen these concepts previously, so they are already aware of how they work before using them with their Arduino. There are quite a few CodeHS courses that provide this prerequisite information to students, as noted here. One important thing to keep in mind is that our Intro to Programming with Carol course does not include information on variables. So if you are using this course as your prereq, you'll need to supplement with some information about variables and parameters before students see these concepts in the Arduino course. There are a few ways these prerequisites can be implemented. Students join your class after they have taken one of the courses listed. This could be before they joined your class, completed as a summer assignment, or as the first semester of your course if it is a year long. Another option is to have students learn these foundational concepts concurrently as they take this course. This could be provided during another class period if your students are lucky enough to have 2 periods of computer science, or could be threaded into the intro programming course. Let's take a look at an example of how this could work. If your students are completely new to programming, you can use these year-long courses that integrate the Arduino course into the Intro to Programming in JavaScript and Intro to Programming in Python courses. This enables students to learn the prerequisite skills they need to know before applying them to the Arduino device. An important note, the Arduino device uses the C++ language. This language is syntactically closer to JavaScript than Python. This means that if students are learning concepts in Python, there will be a larger leap in order to apply these concepts to the C++ syntax. The concepts are the same, and the videos and explorations within the Arduino course will provide students with the bridge they need to jump from Python to C++. If you are planning on teaching this course in a virtual setting and are wondering if it will be possible, the answer in general is yes. Due to the online Tinkercad simulation platform, all but one of the activities in the first 2 modules of the course can be simulated. The difficulty will arise when teaching the final module, as students will be creating their own projects. Now let's look at some of the differences between this course and other CodeHS courses. In most other CodeHS courses, programs are written, run, and graded all on the CodeHS platform. In this course, we will be using Tinkercad, which will allow students to develop, test, and simulate their programs. They can then upload their programs to their physical devices using the Arduino IDE. The second difference to note is that in many other CodeHS courses, teacher resources such as lesson plans, handouts, and problem guides are only available to teachers on the Pro plan. Due to the unique nature of this course, all of the resources are provided to every teacher on our site. We'll cover all of these resources in the next lesson. The final big difference you will notice is that students will not initially be told how a command or a sensor works up front. They will engage in explorations to figure this out for themselves. After students explore sample programs and make hypotheses, they will be able to watch a follow-up video which will synthesize the information we expect them to have learned to be sure all students are coming away with the same correct knowledge. Now that you've gotten a bit of information about this course, let's dive into some activities.